Okay, question 1. What is the molarity of a solution prepared by dissolving 2.50 moles of NaOH in enough water to make 625 milliliters solution? So we're looking for molarity, and we're given some moles and a volume. So remember that molarity equals moles over volume, and volume is usually in liters. So we want to do our molarity equals 2.50 moles of NaOH divided by, and if we're doing liters, 625 milliliters. If you move the decimal over 3 spots, you get liters. All right, so that equals 4.00 molarity. Question 2, you want to rewrite it, or I'm going to rewrite it so that we have room for our coefficients. PbNO3 plus Ki yields PbI2 plus KNO3. Okay, so remember, if our polyatomic ions, which is nitrate, stays intact, we can keep those intact when we're balancing. So we have lead, we have nitrate. I'm going to keep that intact instead of splitting it up into nitrogen and oxygen. We have potassium, we have iodine. Over here we have the same, obviously. Okay, so on the left side we have how many leads? We have 1. Then remember, we're looking at, for the nitrates, we're looking at this subscript that's outside of the parentheses. We want this subscript, right? Because this one is a part of the polyatomic ions. This one's telling us we have 2 nitrates. Okay, and we have how many potassiums? 1, and we have 1 iodine. And then in the products portion, we have 1 lead. And then again, we're looking at the whole nitrate polyatomic ion, and there are no parentheses around it, so we just have 1. We have 1 potassium and 2 iodine. You can hear my son's playing video games in the background. Sorry about that. All right, so our lead is balanced. We have 2 nitrates in the reactant side, so we need 2 nitrates in the product side. Okay, so we're gonna update that. And now we need 2 potassiums over here. So now we have 2 and 2. And if you look across, we have 1, 2 nitrates, 2 potassiums, 2 iodines. So look at our answer. We want to do D. All right. How many moles of NaCl are in 150 milliliters of an 0.4 solution? So to decide between using the dilution equation or just your regular molarity equation, you want to look at what's present. We have moles present. We have a volume present. I'm sorry, we don't have moles present. We have a volume present and a molarity present, and we need moles. So we're going to use this guy right here. He has everything we need. But we're solving for moles, which is the N in our equation. So we need to rearrange this equation so that it equals N, which stands for moles. We do that by multiplying volume by both sides, okay? And that's gonna give us volume times molarity equals moles. So now we have 150 milliliters, and remember, if we take the decimal, move it over to the left 3 times. That gives us liters. So we have 0.150 liters times 0.4 molarity. And that gives us 0.06 moles of NaCl. So that would be D. Okay, I'm gonna do one more problem and then restart the video just because it only lets me upload the shorter videos. So number 4, we want to calculate the number of moles of KCl in a 15-gram sample. Okay, so what do we want? Always ask, what is it asking? It wants us to calculate the number of moles of KCl. It's going to be on our equal sign. And it gives us a 15-gram sample of KCl. Well, how do we get rid of grams from the top and get moles? So anyway, what do we need to do to get rid of grams? Well, we have to multiply grams on bottom. So he gives us a molar mass, which is 74.5 grams per KCl, per 1 mole of KCl. And our answer, we wanted moles of KCl. We have mole of KCl on top. You can cancel out our grams. And I get 0.201 moles of KCl. So that is A. Okay, I'm gonna start another video.